Okay, more propagation. Radio horizon. Ground waves. You know about ground waves, right? Good.
Low frequencies, that's good.
Yep, all right. Propagation prediction techniques and space weather. So the radio horizon basically allows you to transmit farther than line of sight. And they have a formula for the line of sight distance, which is based on the circumference of the Earth and the height of your transmitter. And it turns out that constant is 1.21 times the square root of the height. So if you had a handy-talkie and you're holding it up probably 5 feet off the ground, whatever the square root of 5 is, times 1.2 is going to be your line of sight range. So just rough math says that's only a couple miles. The radio horizon is due to the fact that the density of the atmosphere changes and it's denser at the surface than it is higher up. It actually causes, they don't call it refraction, but I do, because it actually bends the wave because it's delayed more closer to the surface than it is farther away from the surface. And it's just like optical bending. So it tends to cause it to curve and follow the curvature of the Earth more. They estimate it by assuming in the same formula that the diameter of the Earth is 4/3 instead of 3/3. And it turns out that it's a simpler formula. It's the square root of 2 times the height. So now your 5-foot thing would be square root of 10, which would be the distance. When I multiplied it out, I got about 17% difference. They say 15, but somewhere in that range. But I think that's just a guesstimate because I think other things can affect it and you might get more or less mileage. So how much does the VHF, UHF radio horizon distance exceed the geometric horizon?
Alpha.
Unfortunately, they don't have any other answers that are close to 15. So
15% more.
Yeah.
In the line of sight.
Yeah.
I think you're right.
Yeah.
I know at 10 feet, your visual horizon is 6.867284834 miles.
Okay.
According to calculating the diameter of the Earth, assuming it's round.
At 10,
Yeah, which is
at
not.
10 feet.
Well, it is around the ocean, pretty much.
Well, okay.
So you said at 10 feet?
Huh?
At 10 feet?
At 10 feet, it's 6.8 miles.
So I gotta do this?
Yeah.
Okay.
So
So
it means
if going from here to here, how much can I get another half a mile or?
Let's say another foot, 2 feet. Is that 12?
so that means the antenna on your car for 2 meters is only going to get like 6 miles or less.
Well,
Or
that's,
less?
yeah, but if somebody else is, there's a 6
Yeah,
feet.
but see, the other guy gets the same, depending on how high he is.
Right. The repeater.
So 2 handhelds, you kind of double it. You're both at 5 feet.
Screwed up.
Okay, so what does the radio path horizon distance? Why does the radio path horizon distance exceed the geometric horizon or line of sight?
It's delta.
Ground waves. They're frequency dependent. So the higher the frequency, the less effect or less distance ground wave has. This says that vertical vertical polarization is the best type for ground wave. I guess that means vertical antennas because they're bouncing off of the ground plane.
I think it's because gravity bends light, so it's also gonna bend radio waves. And they have less energy, so they're gonna bend further. But the Earth's gravity is gonna pull it down.
The
That's my
gravity-
theory.
The gravity doesn't bend light that much though.
Well, it doesn't, because light is very strong, very high frequency. Has a lot of energy. Where radio waves, this is the same type of waves, just a lower frequency and it has less energy in it, so gravity has more effect on it. That's my theory.
So it has more effect on power lines then.
That's why I get so much noise in my phone.
Okay.
That's-
I think it has to do with that it won't propagate.
I don't know.
Isn't it the launch angle also it affects that?
For what?
I
The
don't
launch
think it
angle
affects
on
ground
a
wave.
vertical? Okay.
Yeah, it's lower. so-
Because if you got a vertical at 160 meters,
Yeah,
there's no way you got a low elevation angle unless you got 1,000-foot tower.
That's why it has such good ground wave.
Well, I used to work at a ground wave site and the antenna was 1,100 feet high. And it transmitted at below the AM band.
Oh. So what is that, meters?
That's 300
300,
meters.
400 meters?
350, man.
Okay, yeah, I don't know how ground wave really works.
Just doesn't use the atmosphere.
Okay.
1,100 feet above ground level?
Yeah, I've heard of some
That's it.
1,000-foot. In fact, I think there's one in Orlando up in that height.
Isn't that one up like Christmas, isn't that over 1,000 feet?
Might be. How does the maximum range of ground wave propagation change when the signal frequency is
hey
increased?
Melanie,
What'd you say?
sorry.
You were talking to somebody else?
Yes,
All right, Michael, what's the answer?
it's Charlie.
Right.
As you said.
What type of polarization is best for ground wave propagation?
Vertical.
Okay, prediction techniques. Well, one of the things we talked about was the Hepburn maps, but there's also a software package called VOACAP that was developed by the Voice of America. Didn't that used to be RCA back in the day?
I don't know, maybe they ran it. It was down in
Some-
North Carolina or someplace.
Yeah. But you can get this VOACAP software and it'll model HF propagation. I have not tried to find it and download it. Maybe in the future, after I finish all my other projects. So what does VOACAP software model?
Charlie?
HF propagation. There's also packages to do the propagation modeling that use what's called ray tracing. I'm only familiar with ray tracing from doing video stuff like POV, which does ray tracing for graphics, and it takes every possible ray from every point and traces its reflections and stuff and gives you these fantastic images that take hours to process. And I assume this kind of works the same way. It just traces the path through the ionosphere. So what does the radio communication term ray tracing describe?
Modeling a radio wave path.
Bravo. Okay, a lot of the prediction software uses some of this other data, which is called the A index and the K index. They're measures of geomagnetic activity, and that definitely affects propagation. Increasing A and K means increasing disruption of the geomagnetic field, which means you're getting more solar material, more solar flares. And that tends to degrade propagation. So rising A and K is not good for propagation. And for some reason, the polar paths tend to get more absorption. I don't know that I understand why, I just believe them, when you have elevated A and K or increased geomagnetic activity.
That's where the magnetic poles of the Earth are interacting with the ionosphere, I think. So, of course, the geomagnetic field around the poles is really going to be severe.
Yeah, and there's another thing coming up where it has to do with whether the geomagnetic lines, they call it interplanetary magnetic field, is north-south or not, which is related to that. I think that's the next
Lines
slide.
of flux or whatever.
Yeah. Oh, they call it interplanetary magnetic, which confused me because that sounds kind of spacey and not within the Earth. But well, maybe that is right. I guess correct would be intraplanetary between planets, right?
Yeah,
Outside.
And interplanetary is one
within,
All right.
I think.
That one confused me. All right. What's indicated by a rising A or K index?
Alpha.
Very good. Which of the following signal paths is most likely to experience high levels of absorption when the A or K index is elevated?
Polar.
Now there's the ARL, well, there's others, puts out a thing every day with all this information on A and K and all those other parameters. If anybody is interested, I get them. I haven't figured out what to do with them. It's just
They make pretty pictures.
another thing cluttering up my inbox.
It is complicated.
I know.
Very complicated.
The interplanetary magnetic field definitely affects propagation, and they have a parameter called B sub Z, which represents the direction and the strength of the Earth's magnetic field. If its direction is southward, I guess it really should be north-south, although I guess they're referencing it North Pole to South Pole, probably, why it's southward. It increases the likelihood that solar flares and other particles coming out of the sun, coronal mass ejections, will cause disturbed conditions. So propagation is poor when BZ is southward and there's geomagnetic activity. So what does the value of B sub Z represent?
Charlie.
All right, direction and strength of the interplanetary magnetic field. What orientation of B sub Z increases the likelihood that incoming particles from the sun will cause disturbed conditions?
Alpha.
So that must be talking about from North America.
Hey,
Does that only apply to the northern hemisphere?
would still be
That's what I
going
was
south
wondering, the
to
same
southern.
thing.
From north to south, regardless.
Right, it's saying that if it's southward, it's gonna affect, you know, the whole northern hemisphere. If it was northward, it'd probably miss the earth or, I mean, not affect, not interact with.
Well, I wonder if it has to be vertical. Could it be at an angle or horizontal?
But it almost seems like it's talking about the.
I mean, it's always shown,
Northern hemisphere.
you know, like a magnet, north and, you know, vertically.
Yeah.
I'm not sure how the direction changes myself.
It'd be interesting to see if magnetic poles split within our lifetime.
Well, now that's a
What ki-
different,
yeah,
that's a
what kind of-
different
Yeah,
problem.
what kind of chaos that'll cause?
Okay, so southward. Space weather. Let's see. Solar flares, which we hadn't talked about. Emit a lot of radiation in the form of ultraviolet and other things, as well as material, which is ionized. You can get protons and electrons coming out, and that's what really affects the geomagnetic field. So the more material and radiation coming out of the sun, the more it affects propagation. And too much can reduce propagation, just the right amount makes it good. You need some, but not too much. And that's what the next couple things do. If you got just the right amount of radiation where you're ionizing the F1, F2 layers, then you can get propagation off the ionosphere. If you get too much, it gets down to the lower layers and activates like the D layer and E layer, so you get more absorption. So it tends to decrease propagation.
It's talking about the solar wind, right? It's like the blast of particles from the sun.
Well, there's solar radiation. There's solar flares, and there's coronal mass ejections, where it throws out actual
Huge.
physical material in big chunks, which can, I guess, what is it, a G5 or something like that, could wipe out radio communications for days.
Extreme. Yeah.
And I think that's probably the next one coming up. So what might be indicated by a sudden rise in radio background noise across a large portion of the HF spectrum?
Solar flare.
Solar
Yeah.
flares. As opposed to sunspots. Sunspots are good. Solar flares are bad. They categorize the solar flares by intensity, and there's classes A through X. Now, I couldn't really find anything about A, B, and C. Most of the stuff that's posted deals with M and X. And they go from 1 to 9 in each one of the classes, and each level is 50% more than the previous level. So it's kind of logarithmic.
It's kind of like the Sanford Simpson scale.
So this is typically what I could find, and nobody ever talked about A and B. I guess they're kind of insignificant. But X is the one,
Weekly occurrences. That's why they're just,
the X class is the largest one, and X9 is the most severe. I don't know if we've had an X9,
Don't know anything.
but apparently it can do a planet-wide blackout.
I
We haven't had that lately.
hate to be in an aircraft when that happens.
Yeah, because it can affect all kinds of, not just radio
Your
waves.
health,
uh, Power stations, power
your
lines.
health.
Which of the following descriptors indicates the greatest solar flare intensity?
Delta.
How does the intensity of an X3 compare to that of an X2?
A difference
Bravo.
to me.
Okay. NOAA came up with what they call space weather scales. And this is a G scale to indicate geomagnetic conditions, where G5, which I believe is the highest one, is an extreme geomagnetic storm. And there's a chart which you probably can't read, but it shows G1 through G5 being G1 being minor. You might have power grid fluctuations, could impact some satellites, could affect migratory animals. I guess birds don't know where they're going. All the way up to a G5, it says you could have widespread voltage control problems, protective system problems, grids might collapse or have blackouts. You might blow up transformers. Spacecraft may have extensive surface charging. I guess that's charge built up on the outside due to the magnetic fields going by. HF propagation impossible. More stuff on power systems. So G5 would be bad news.
It says there the aurora has been seen as low as Florida and Texas during those events.
Have we had one of those?
I've never seen one, but you mentioned you saw the aurora in Florida, no?
Nope, never seen it.
What does space weather term G5 mean?
Alpha.
Means get in your bunker. Sunspots. They're also used to predict propagation. And the more sunspots, the better for HF. I'm not sure how they affect UHF and microwave, if
I
they
have
do.
no idea.
They use the parameter called 304A, which represents 304 angstroms, which is the wavelength of the ultraviolet emissions that they're measuring. And that somehow correlates to what they call the solar flux index. So by measuring the emissions at that wavelength, they come up with this solar flux index. And the solar flux affects the F2 layer's ionization. So what does the 304A solar parameter measure?
Three oh four angstroms.
Yeah. Ultraviolet, 304
Yeah,
angstroms.
bravo.
I forgot what an angstrom is, but it's pretty small.
Is it 5 to make a micron or something like that?
It's down below nanometers, I guess.
5 to make micron.